While we are highly trained professionals operating in extremely complex mathematical operations, we do encourage you to try this at home because it will help you achieve a greater understanding of mathematics and hopefully improve your exam grade. Thank you and enjoy the show. So here we have an exam style question split into three parts. It's covering in the main two learning objectives. The first one is learning objective 1 to be able to calculate bearings. The second one is learning objective 2 to be able to use the sine rule and cosine rule to calculate measurements. Also, the area rule will be used. So we've got a diagram, and it says that the diagram is not drawn to scale. So you can't just get your protractor out and measure an angle or measure a length with a ruler. So what do we do? Well, question 1 says, work out the bearing of A from B. Now the crucial part of this is the language of the question. It says A from B. Now when we're calculating bearings, we measure from north. So we're going to be measuring the turn from B to the direction of A. So we're going to be measuring this angle here to calculate the bearing. Now we're going to do this using angle rules rather than actually using our protractor. So what I'm going to do is I'm actually going to identify a way of finding this angle using corresponding angles. So we've got this information here that angle CAB is 120 degrees. And we can actually use that to calculate the bearing of A from B, i.e. this entire turn here. So what I'm going to do is I'm actually going to continue the line AB. And now we can see that we have an F angle here. F angles are corresponding angles, fangles, and it means that between parallel lines, obviously the two north lines are parallel, that these angles are going to be the same. So this part of the turn is going to be 120 degrees. And the other part of the turn is a straight line. So that's going to be 180 degrees. And all we need to do to calculate the bearing is add these two angles together, and basically the bearing of A from B is going to be 300 degrees. And that's your solution. So just to kind of recap what I've just said there, we've identified some corresponding angles by continuing the line AB, and then we're adding the straight line angle, which is 180 degrees, to the corresponding angle. So 120 degrees plus 180 degrees equals 300 degrees. Now moving on to part 2, calculate the length of CB. Now this is moving into a different direction and tackling learning objective 2. Now we have some formulae in our exam booklets, and it's the sine rule and the cosine rule and the area of a triangle. Now I call the sine rule the pair rule. Now it's a little play on words because I'm really talking about a pair. And when I'm talking about a pair, I'm talking about big angle A and side A. That would be a pair. Big angle B, so that would be this angle here, and side B. And side B is opposite big angle B. Side A is opposite big angle A. Obviously this will be now side C because that is opposite big angle C. And if you have a pair, you can apply the sine rule. But if you do not have a pair, you're going to have to apply the no pair rule, which is the cosine rule. And I say cosine, no sine, no pair. Cosine, no sine, no pair. Okay, so if there's no pair, it's going to be the cosine rule. And that's a squared equals b squared plus c squared minus 2bc cos a. Now we don't have a pair. Often when you're applying the cosine rule, it's like as if you have a little mountain top like this, where you have the angle and you have two sides next to it. That actually also works for the area of a triangle rule. You have the side, the angle and the side, and you can find the area using those three measurements. So here, let's look at what we have. We have big angle A, we have side B, and we have side C. And for question 2, we need to calculate the length of CB. So that's A that we need to calculate. So we're going to use the cosine rule. The A squared equals b squared plus c squared minus 2bc cos A. So what we're going to do is, as always in IGCSE, we're creating constructs. So we're going to write down that formula and start to substitute into it. So we've got a squared, which is the square of the measurement we need to find, equals b squared plus c squared minus 2bc cos A. So we write down the formula and then we go about substituting into it what we know. Now it's quite similar to Pythagoras actually with the a squared equals b squared plus c squared. But obviously you've got the minus 2bc cos A. So we don't know what a squared is. So we've got 150 squared plus 275 squared. And always show all of you working out, because even if you make a slight error, you're still maximising your chances of getting as many marks as you can. 2bc cos A, I'm going to put it in brackets. It's 2 times 150 times 275. I'm running out of space slightly here, so I'm just going to put this onto the next line before I close my bracket, times cos 120. So now this is where I go to my calculator and work this out very carefully. I would recommend that you calculate it twice just to be sure that you've got the right answer. So 150 squared is 22,500. 275 squared is 75,625. And now this is where you need to be a little bit careful. 2 times 150 times 275 times cos 120 actually gives you minus 41,250. So the minus would be a plus. Now obviously again you're going to calculate this, so you come to the point where you've got a squared equals 139,375. So then we need to square root this value to give us a. So we're going to do the square root of 139,375, and that is 373.3296. Now the question might ask you to round it to 2 decimal places, in which case your length A is going to be 373.33. Don't forget your units as well, it's going to be centimetres. So that would be your answer to question 2. Now finally we have to find the area of the triangle using half BC sine A. So I'm going to do this over here. Half BC sine A. All we're going to do is we're going to say, right, well, we've got the values B, C, and big A. So the area of the triangle is going to be half times 150 times 275 times sine 120. Put that into your calculator very carefully. Maybe do it a second time just to check your answer, and you should get 17,861.7739. I'm always in the habit of writing down a few extra decimal places before I round it, and then if the question asks me to round to 2 decimal places, I can then demonstrate what I'm doing just to make sure that I don't drop any marks. So it's going to be 0.77 to 2 decimal places. Don't forget your units, it's going to be centimetres squared. Okay, thank you very much and see you next time.